Hello, and welcome to my talk, Exploring Data in Notebooks. In this short talk, I'll be talking a little bit about how you can take some data, load it into a notebook, and start visualizing it really easily. So just as a sort of context, everyone knows that Python has become a really big language for data science. And you have all these different libraries now in ways of expressing your data, whether it's Pandas data frames, or maybe Xarray arrays. But the key thing is that there's basically two types of data that we see in the ecosystem nowadays. At least two commonly seen types of data. You see columnar data or tabular data, which is often things like data frames. And you also see things like raster data, which is sort of traditionally be something like NumPy arrays, or nowadays you get labeled multidimensional data like X arrays. Now, this whole ecosystem is kind of overwhelming at times because you have so many different tools. But what I'd like to show you is that there's now one simple way of exploring all these different types of data with a very simple plotting API. And the idea here is that you can load your data, and no matter what it is, start getting some insights into it. Spot outliers, see trends, and get insights into the data that you might not have had otherwise. And you also want to be able to do this without always thinking about the details of plotting. You want a simple API that you can use, and without thinking too much about it, just concentrate on your data and see what you can get out of it. So some of the examples that you might have of data types include, of course, Pandas data frames, but you also have Dask data frames or Rapids data frames, GeoPandas also has data frames, Streams, which is a library that does streaming data, that also has data frames. And all of these things have similar kind of API with, of course, various differences that you might need to think about. So one idea of what I'm going to be showing you is there a way to unify plotting across all these different types of data frames, but also, can you actually plot array data as well? Can you have a similar plotting API that also applies to NumPy arrays and X arrays, which are kind of a very different structure. So in columns, you have arrays of high dimensional types. So this project that you're looking at right here can be downloaded on this link right here, which is an Anaconda project, which I've uploaded. It's an archive. If you download it, you'll see this notebook. You also see a companion notebook in another talk that I'm doing about reproducibly capturing the code. So if you have any troubles following along with me or running this notebook, read that notebook, maybe see my other talk, and then you'll hopefully have a way of actually getting all the libraries and dependencies and things you need to actually be able to run this. But I won't go through that here. I'll just be talking about the visualization side of things. So the API that I'll be talking about is called the .plot API. And it's something that came with Pandas and is inspired by Pandas, where instead of .plot, you'll be using something called .hvplot. And that's the library that you'll be installing. But first, I should talk a little bit about what .plot does in Pandas on a data frame before anything else. So this is just vanilla Pandas, nothing special. What can you do with just pure Pandas? So I will start by importing Pandas, qualified as PD. And what is the data that I'm loading? Well, it's some disease data, which is the link here, which is talking about measles and some other diseases through the 20th century. It's measured per 100,000 people in terms of incidence rates, and it's the United States, and it's broken down by states. So you have all the different states in the US from 1928 to 2011 in this data frame. So let's have a quick look at it. Let's load it and see. We have, as I said, starting at 1928, different states. So here it starts with Alabama. It's the top of the data frame, so it's the head. And it's got measles and pertussis as well. Okay, so what happens if we just load this notebook magic called matplotlib inline and call plot? Well, we get something. We get something that shows all our data. It's hard to interpret. It's not interactive. It's just an image on the screen. But it has actually plotted all our data. So before we can really do anything, we need to do something with this data frame, process it a little bit so that it becomes something that we can interpret easily. And one way to do that is just import NumPy and use the aggregation or aggregate function on Pandas after grouping by year with the sum. So this is the sum over the year where you've got the year, and we're just looking at measles here. So measles summed over the years, very simple data frame, indexed by year, and measles is the total. Okay. So what happens if we call plot this time? Okay, now this makes a lot more sense. We can actually interpret this. You can see how much measles is happening in these years, and then you see that somewhere around here, it just dropped to almost 0, and by 1980, it's very close to 0. So we have something. We can interpret it. Why do we need anything else? Well, why might we want something more than just the dot plot API that ships pandas? Well, one thing is we don't have any interactivity, and we might have trouble building on this plot and composing it into extra things. So let's see what happens if we import hvplot pandas, which adds an hvplot method to your data frames. Well, now we can actually start doing things. We can start scrolling, we can start panning. We also have this little hover button here, which lets us actually hover over different dates and see exactly how much measles was happening at those different dates. So this is quite nice because you had no interactivity before, but now we can focus on sections of our data and so on, start things about precise values by hovering over them, and et cetera, et cetera. So here we're using something called Bokeh. It's not matplotlib, it's an interactive library that works in the browser and works in notebooks. It's not static like what you get within a matplotlib image. We now have this toolbar, which gives us all these different affordances, these different tools, and we can now do new things, like I said, like hovering. So what else can we do with hvplot that you can't do with dot plot, or not easily? Well, I just mentioned that there's this sort of transition where it has high measles to low measles, and you might think about that and might want to have an explanation for this, some sort of causal explanation. Well, turns out 1963 is when a measles vaccine was introduced. You can read all about it in this link I have from the CDC. And that is the vaccine that brought the measles incidence down. So we might want to capture this information, this knowledge on our plot, and while keeping all our interactive tools. So how do we do that? Well, the thing about hvplot as a method is it returns something. It returns a HoloViews object. Now HoloViews is got a link here. This is what is returned by an hvplot call. And these are composable objects. You can start combining them in different ways to make more and more complex plots. So let's have a look at it by printing it. So if we print it, you see it's something called a curve. Again, you can click here on the guide, open it up, and we have a reference code in HoloViews that talks all about what we call curves. Other people call them lines, but it's an object that has a representation that you see on the screen. It's interactive with this bokeh visualization. What's different, it's not a plot object. It's not a matplotlib or bokeh object or anything. It's its own entity that has a representation. And you can tell this by looking at the .data attribute. This is essentially the data you put in, held in this object, and when you just do hvplot obj by itself, the notebook displays it in a certain way. It's not a plot, that's the key point. It is a separate type of object. So what we can do now is importing from HoloViews, we can start creating some things. There's a thing called vline, which might be interesting if I open up the reference. You can see it does vertical lines. There's also a text object, which you can also open up. It lets you write some text. So you might think, well, maybe I want to put some text on my plot and some vertical line to mark 1963. So that's what I do here. I create a vline object, style black. There's a style system HoloViews you can use. Create some text with some string, which is vaccine introduced, and a position, which is 1963, and a measles incidence rate. It's all in data space. What you can do is using this little mul operator, this little times operator, you can actually overlay all these things into a composite object. So you take all these objects, combine them all together, and what do you get? You get something that's still interactable, can still zoom, can still hover, etc. But now you've captured the information that you had about the vaccine. Zoom out, and I can set the plot and so on. So everything I had before, I have it, but with the extra information I've captured about the vaccines, which is more difficult to capture otherwise. Now, if we look at this object and print it, we can see that it is a composite, something called an overlay, that's composed of this curve, this vline, and this text. Okay, so that's just a very, very small taste of what you can do with hvplot, but there's more. This is some interactivity, but most of the interactivity we have right now is given to us by bokeh, and we have the compositionality of HoloViews, but we haven't really got any different types of interactivity. So what we're going to do now is do something slightly different. And we're going to take our data frame and keep the state information there. So what we have now is a breakdown by state for each year, how much measles was happening in that state. There's a simple expression, it's a group by in Pandas with a sum. And what we have is this new data frame, which has got two different dimensions to think about. Well, you have the data value, which is the measles, that's the value you care about. But then you have the breakdown by year and state. So what's interesting now is we have this new data frame. We can call in hvplot, we can say group by state that we're plotting over year. And this time we get something, a little drop down. Now we can actually just jump through our different states And we still have all those interactive tools which are really nice that bokeh gives us, the hover and so on and so forth, as well as our V-line. So you combine the interactivity of bokeh, some interactivity given to us by HoloViews and hvplot in terms of this drop-down widget, as well as this annotation that we have where we can see where the vaccination was used. There's a lot of information that we've been able to put together into a single little visualization. Now, I'll talk about some of the quick features about hvplot which make it even more compelling. These are not using the same data. We'll start loading some different data. I'll show you that you can work with Dask data frames and Xarrays. So for this, I'm going to start with a sample data set which is supplied by hvplot, which is airline flights. This is quite large. I'm going to turn it to a Dask array, so a Dask data frame, and I'm going to persist it, and I can look at it. So this takes a little while to load. It's quite large, and you'll see that there's now 918,000 odd points in this thing, giving me information about flight dates and months and days and times, carriers, and so on and so forth. Lots of information in this data frame. And if you think about it, if you just try to plot it with the scatter, that's going to be a lot of points, and it's probably going to crash your browser. You might even take a lot of memory on your server, in your Python process, and so on. So now we have Dask. Let's try and plot it with hvplot, but instead of doing this, which is what you normally do, just create a scatter with the distance and airtime as y, which would be the scatter HoloViews objects, which you would then display. If you did display it, you might crash your browser and so on. So what you do is you supply this extra keyword, which is datashade equals true. This is using a library called datashader. And what it does is it turns all the data that's in memory on Python and rasterizes it. It turns it into an image and sends that to the browser, so all those points. What's really cool is that you can keep all your interactive features and actually explore all the data at once with your panning or zooming. And one thing I haven't shown is you can actually zoom on a specific axis. So I can compress the x-axis this way while keeping the y-axis within a certain range and so on. So I've got all my interactivity, but for this really large data set. For that, of course, you need to have datashader installed as an optional dependency. But all you need is datashader equals true, and then even a really large data set, which would otherwise cause trouble, can be easily and interactively visualized. Okay, so next I'll talk about Xarray. So I've talked about data frames a lot, just to show you that you can still do things with Xarray, with datashader, all combined. We can now import Xarray and load hvplot.xarray. This is how you add the hvplot method to the Xarray objects. And let's have a quick look. So we've got this data set which is included in Xarray, which is Xarray tutorial. You can load it, print some data about it. It's some data that's about air temperature. It's got dimension of time, latitude and longitude. And here's the dimension. It's quite large, so you'll want to use datashader for it. Okay, it's three-dimensional. You can see that there's these three different dimensions here. Now, we can call scatter with datashape, because it's quite a large data set, on this thing, which is now a Xarray object. So we do that, we get our data shaded Xarray plot, which is now raster data as opposed to data frame. And again, if you zoom in, you can interactively zoom in, and you can interactively squash different dimensions, and so on and so forth. Or zoom in and so on. Okay, this might not be all we want, though. We might want to use that compositionality that you get with HoloViews. So you might want to do a different plot, where this time we're going to make a line plot where we take the mean over latitude and longitude. We're just going to collapse latitude and longitude away, take the mean across all latitudes and longitudes. So we get a plot of temperature over time. It's just a simple mean that we take with Xarray, call hvplot with the time dimension as the x-axis, and then color it with the Indian red color. So now we have these two things. With HoloViews, all we need to do, once again, is call this little mul operator to create an overlay that puts one on top of the other. So here we go. And now we have a plot that's combining different types of information. You could have the text that I mentioned, you could have the V-line that I mentioned earlier. You do all these different things, building a more and more sophisticated plot that is plotting large amounts of data with interactivity as you go. So again, I could do a little box zoom, and again, it's loading the data as I zoom in and out. It can handle large data sets, and you can actually see these little wiggles, which you might not see when you're zoomed out, that I hadn't noticed, letting you see aspects of the data that might not have been immediately obvious if you just have a static matplotlib plot. If you don't explore it, you might not realize that it has more structure than might appear at first glance. So, oh, and of course, just to point out, each little bit has hover. So this is the hover information from my average curve that I can explore over time, and so on. We set it, that's the final plot. And the thing I would say is that this is just talking about Dask and Xarray and Pandas, but there's so many different things that hvplot supports. You can use streams for streaming data, data that's coming in live. You can have live plots that update automatically as new data appears. You can do things with QDF. You can do stuff with GPUs and so on and so forth. There's a lot of really cool stuff that's supported. And there's also things you can do with HoloViews, like link selection and things. This is all advanced stuff. So if you're interested, you can go to the hvplot user guide, which is here, where you can talk about things like network graphs and things with network X and all sorts of different things you might be interested in looking at. So I encourage you to do that. And also, I encourage you to look at holoviz.org, where you can find information about all the different libraries that are part of the holoviz ecosystem, including, of course, hvplot. So I have another talk that's based on this notebook where I talk about how to get all these dependencies available to your environment in a sort of reproducible way, so you can run this notebook without worrying about, has this person been able to get all the right versions of everything and so on and so forth, which is part of that project I mentioned, and it's also part of a talk that's my next talk. So I hope that was useful. I hope that's informative and gives you a taste of what you can do with hvplot and the sort of visualizations you can generate very quickly. It's very simple. .hvplot API. So thank you for listening, and hopefully you'll check out my next talk. Thank you.